Now friends, here Hemant bought a car with a listed price of rupees 4 lakh. Thanks to Hemant's good relations with the auto dealer, he got two successive discount of 10% and 20%. Now two discount 10% and 20%. That means final discount will be suppose we start with 100. That 100 minus 10, that's 90, and 90 20% of 90 is 18. That means finally he is paying 72. That means 28% discount he is getting, right? So what is the price that is paying? 72% of 4 lakh, right? After buying the car, he spent 10% of the purchase price. This is the purchase price. Now he's spending 10% of that. That means the final cost has become 110% of this. So that's 1.1. On buying accessories for the car. At what price should he sell the car to earn a profit of 20%? Now this is the cost price. Now he wants to earn a profit of 20%. That means the selling price should be 1.2 of this. Okay. Now friends, 4 lakh, we have 5 zeros. So 1, 2, 3, 4. This cancelled. We just are left with 1, 0. That means after all the multiplication will be having 0 at the units place. So this is the incorrect option. And even this will be incorrect because 00 cannot be obtained because we don't have any 5 over here. So even this is incorrect, right? Now after that, what you can do, you can choose between this and this just by looking at the unit digit, right? We just drop 0. 4 2s are 8, 8 1 is 8, and 8 2 is 16. So unit digit must be 6. So obviously this is the correct choice. You don't have to go for any sort of multiplication over here. Be very careful about it. Okay. So friends, this way you can save the time, and you can even match the digital root as well. Between two options, the digital root of this will be obviously 9 because we have a number over here that is multiple of 9, right? So here it is 8 plus 3, 11, 12 and 6, 18. That means the digital root is 9. And here it is 7, 8, 9. And even here the digital root is 9. So the unit digit method will be better. Okay. But you should be having an open mind for both the methods. Now friends, over here, a letter stands for each digit between 0 to 9, including both the digits. No two digits for the same stand for the same digit. Here AB square is CBB and DE square is GDE. We have to find out the value of A plus B plus C. Now friends, B square, and we are getting the same digits at the last two places. So it happens only in the case of 12 square. So 12 square is 44, but here it is 12. So 12 square, even it is incorrect. That means B has to be 0. So if we have 0 at the unit place, and if we square that, we'll be getting 00 over here, right? But we don't know about A, right? So if we don't know about A, we cannot calculate C. Maybe it's 10, maybe it's 20, maybe it's 30, maybe 40, 50, 60, whatever, right? So what we have to do, we have to calculate the value of other alphabets also. So we can calculate the value of A. Now here DE square is DE, right? It happens only in the case of 25, right? 25 square is 625. So it is D, it is E, it is G, D and E, right? Now friends, obviously C should be a perfect square number, isn't it? So we have the three options for C, that is 1, 4 and 9. Now C cannot be 1 because if C is 1, that means A has to be 1. But no two letters stand for the same digits. So it's cancelled. Now C cannot be 4 because if C is 4, A will be 2. And if A will be 2, 2 is already assigned to D. So even this is not correct. That means C has to be 9. And that means A has to be 3, right? So it is 3 plus C is 9 and B is 0. So 9 plus 3, 12. Okay, a very simple knowledge of numbers has been used over here. I hope you are clear. Now if 1, this and this are in AP, then what is the value of X? An excellent problem based on logarithm. Since these three terms are in AP. Now this is base 4. here it is 2 and here it is 16, right? So this can be rewritten as just log, I just write it over here, 4 raised to x minus 2 whole square, right? So this is 2 and this is 2, so they will be cancelled, and finally this will be log 4 raised to x minus 2, right? And 1 can be written as log 4 to the base 4. Now this and the third one, all of this 3 are having the base as 4 and the 3 are in AP. Now you need to think 2 step more, but you don't have to write them. Now if these 3 are in AP, what will happen? 2 times this term will be this plus this, right? And in case of logarithm, log A plus log B is actually log AB. That is what is actually happening over here. 4 raised to x minus 2 whole square, 1 square of this middle term, because 2 will be over here, so finally it will be going over there in the power. So this square is equal to this into this. That means, this plus this. That means log A plus log B, that will be actually log of A into B. So it is 4 into 4 raised to x minus 2, right? And we are taking anti-log. Now we have got a quadratic equation over here and we have to get the value of x, right? So 4 raised to x can be assumed maybe p whatever, right? So it's p minus 1 whole square is equal to 4 p minus 2. So p square plus 1 minus 2p is equal to 4p minus 8. So p square minus 6p minus 9 is 0. So plus 9 is equal to 0. So it's p minus 3 whole square is 0, right? And that means p is equal to 3. Now p is what? 4 raised to x is 3, right? Now we have to find out the value of x. So I just take log x log 4 is log 3. That means x is equal to what? Log 3 by log 4, or I can say log 3 to the base 4, or log 4 by, here we are not given, so yeah, this can be written as, right? It is actually log 2 square 3. Okay, so log 3 to the base 4. So this is another way of writing this. Okay, I hope you are clear. Now friends, let's try this problem. O is the center of the outer circle with radius 5 cm. One of the sides of the parallelogram PQRS is 6 cm in length. T lies somewhere on the line PQ. Find the area of triangle TRS. Now friends, here we are given that PQRS is a parallelogram. Now we must be clear that if PQRS is inscribed in a circle, that means PQRS must be either a square or a rectangle, right? That means opposite sides must be equal, right? Then only it can be inscribed in a circle. So PQRS is a rectangle. Now if PQRS is a rectangle, in that case QS, that will be the diameter of the circle, right? QS will be the diameter of the circle. So QS must be double of 5, that is 10. Now PS, PQ, this is the scene. Now one of the side is 6. Maybe this is 6, then it must be, this is a right angle, then this must be 8, because these 3 are Pythagorean triplet. Now friends, this length is 6. That means this is 6 and this is 8, right? Now what is happening over here? We have to find out the area of triangle TRS. Now what is that? It's perpendicular by base into half. Now perpendicular is what? PS, that is 6. You can take PS as 6 or 8, doesn't matter, because one is PS and other is SR. So precisely it is product of 6 and 8, right? So it is 6 into 8 and half of that, that is 24. That will be the area of triangle TRS. So just a simple logic we have used over here, that if PQRS is a parallelogram and if it is inscribed in a circle, that means it must be a rectangle, right? So I hope you are clear. 24 centimeters square will be the area of triangle TRS. Now friends, here this expression is given to us and we have to find out which of the following is not a surd. Surd, that means an irrational number. Now first of all, let's simplify it and we find out the value of x and y. It's a root 12, that is root 3 into root 4 by 3 root 3. So precisely it is 4 raised to half plus 1, that is 4 raised to 3 by 2 and 3 raised to minus 1. So that is 4 raised to 0.3x into 3 raised to minus 25y. That means 0.3x is 3 by 2. 0.3x is 3 by 2. That means x is equal to 5 and minus 25 by 25y is minus 1. That means y is equal to 1 by 25. Now we got the value of x and y. Now quickly put the value over here and see whether the given expression is a surd or not. Now x is 5, so this is 4th root of x, so obviously it will be a surd. Here y is 1 by 25, but this is a 4th root of y, so obviously it will be a surd. X plus y, that is 5 plus 1 by 25, again 4th root, obviously it will be a surd. X square, that means 25 into y, that is 1 by 25, so finally we are getting 1, so 4th root of 1 will be 1 only, so this expression is not a surd. Right? Now friends, here the problem is based on arithmetic progression. If the first term is given and 19th term is given, we have to find out the sum of this expression. So from these two we can find out the common difference of this AP. So A1 is 5, A19 is 205. So 205 is first term plus n minus 1, that is 18 into D. So D will be 200 by 18, or we can say 100 by 9. Now this one is the first term, this one is the third term, so that can be written as a plus 2d. Similarly the series will go on till a plus 18d, right? So in all a is coming for 10 times, so 10 times a, that means 10 times into 5, that is 50. Then 2d plus 4d till 18d, so I take 2d as common, so 1 plus 2 till 9. Now sum from 1 to 9 is 9 into 10 by 2, that is 45. So 2 into 45 into, I put the value of d, that's 100 by 9. So it's 1050, as simple as that. Okay. Now friends, let's take this problem. Seems and looks to be tedious, but believe me, no paperwork is required at all. Find the value of this expression where a and b are roots of this equation. X square is 1. That means x is equal to plus 1 or minus 1. That means one of them must be 1 and one of them must be minus 1. I assume a to be 1 and b to be minus 1. That means in every case a minus b will be 2, right? So a minus b, a minus b, a minus b, from the entire expression a minus b can taken as common, and that will be 2, right? 1 plus, then I take 1 by 2 as common. Now what is happening over here? A square minus b square, that's 1 minus 1, that will be 0. Similarly a4 minus b4 will be 0, right? And a cube minus b cube will be 2, isn't it? Similarly a5 minus b5 will be 2, right? So this is the third term, then this is third term, then this is fifth term. Similarly we are going up to 9999 term, right? The value of each of them is 2 only, but we have to find out that how many terms are there. Now friends, from 1 to 9999, 1 to 9999, in all there will be 5000 odd terms, that means odd numbers, 1, 3, 5 if we say. So 1 is not there, the first term is not there, so from 3 to 9999 there will be 4999 terms, and value of each term is what? 2 divided by 2, this, and plus 1, right? So that is 5000. Very simple. Okay, I just have written here for your clarity, otherwise no paperwork is required at all. I'm sure you are clear. Now we have one more question based on geometry. In the figure given above, AB is equal to 5 units, AC is 12, DC is 10. We have to find out the length of BD. That means this length we have to find out. Now friends, here this complete angle is 110 degree, this complete angle is 70 degree. That means sum of these two angles is 180 degree. That means this quadrilateral ABCD is a cyclic quadrilateral. I repeat, if sum of opposite angles of a quadrilateral is 180 degree, then this quadrilateral has to be cyclic. That means all the four vertices are on the circle, right? That is actually necessary. You must learn this property. So this is a cyclic quadrilateral and this angle is 90 degree that is given to us. It's a 90 degree sine. So this and this is 5 and 12, that means that must be 13, right? Now if this angle is 90 degree, that means, and this is on the circle, that is the point A is on the circle, that means BC must be diameter. You understand the semicircle property? This, like this. If this angle is 90 degree, that means this must be the diameter, right? Or if it is diameter, then this angle must be 90 degree. Both the things are true, vice versa. So this angle is 90 degree, that means BC must be diameter. Now BC is diameter, then this angle, this complete angle is 110 degree, but this angle must be 90 degree because T is also on the circle. Getting my point? Now this angle is 90 degree. This length you don't know, this length you know, this length you know. So this is the scene where you know hypotenuse and base, and you have to find out the perpendicular, right? So that is 169 minus 100, that is of root of 69. No much paperwork is required. You must be knowing the basic property of cyclic quadrilateral. That's it, right? So angle in semicircle is 90 degree. That is the property we have used. We have used the property of cyclic quadrilateral, nothing else. I hope you are clear. Now in this case, find the remainder when this expression is divided by 17. Friends, this 104 raised to 297. 104 is multiple of 4, obviously, and the multiple of 4 is having a very high power. That means this entire expression is actually multiple of 4. So we can assume it to be 55 raised to 4x, any multiple of 4. Now 55, if we divide by 17, the remainder will be 4, right? 17 3s are 51. So this can be written as 51 plus 4 raised to 4x. So the remainder will be 4 raised to 4x. Okay. If we divide the expression by 17. Now 4 raised to 4x can be written as 16 raised to 2x. Now 16 can be written as 17 minus 1 raised to 2x. That means if we divide the expression by 17, the remainder will be minus 1 raised to 2x, and minus 1 being even power, the remainder will be 1. Right? No much paperwork is required. No much calculation is required. I'm sure you are clear. And this sort of problems we have already discussed in our basic number system session. So if you find it difficult, as I have missed up some of the steps, so if you find it difficult, do revise the session of division, dividend and remainder in the number system folder. Okay. Now friends, we have the question, find the unit digit of this huge expression. Friends, this sort of problems we have already discussed in our basic quantitative aptitude session, where I have discussed how to find out the unit digit of any expression, right? Now what is happening over here? So this is 11 factorial, 12 factorial, 13 factorial, 14 factorial up to 19 factorial. All these factorials are divisible by 4, right? That means these are multiple of 4. That means, see, any number, suppose it is 11 raised to 4k or maybe 12 raised to 4k, right? If we go by the cyclicity of the power, what happens when the number and the power is multiple of 4? What happens? Suppose I take the example of 2. 2 raised to 1 ends in 2, 2 raised to 2 ends in 4, 2 raised to 3 ends in 8, 2 raised to 4 ends in 6. Further the cycle comes over 2 raised to 5, 6, 7, 8, 9, 10, 11, 12, right? So if the power is multiple of 4, even number, and the fourth power of even number will end in 6, right? And fourth power of any odd number, maybe 1, 3, 7, 9, fourth power of all these numbers will end in 1, right? So we don't have to consider the 11 factorial, 12 factorial, 13 factorial part. Okay, whatever the unit digit will be getting, that will be from 11 raised to 1, 12 raised to 2, 13 raised to 3, 14 raised to 4, something like that, right? So 11 raised to 1, that will end in 1, 12 raised to n, that will 2 raised to 2, that's 4, 3 raised to 3, that's 7, 4 raised to 4, that's 6, 5 raised to 5, 5, 6 raised to 6, 6 will end in 6. 7 raised to 7, that will end in 7 raised to 1, 7 is to 2, 7 is to 3, 7 is to 4. So it's 7, it's 9, it's 9 and into 7, 63 and then 1, right? So we want 7 is to 7. So 1, 2, 3, 4, 5, 6, 7, right? That will end in 3. 8 is to 8, further 8 and the power is multiple of 4. So 8 raised to 8 will end in 6. And 9 raised to 9, 9 raised to odd power will end in 9 and 9 raised to even power will end in 1. So it is 9 raised to odd power, so it will end in 9, right? Now this is the combination of unit digit. Let's eliminate them. 10, 10, then 7 plus 5, 12 and 6, 18, 8 and 3, 11, 11 and 6, 17. That means the unit digit must be 7, right? You don't have to go for all this work if you are conceptually clear about the cyclicity of power, right? You just have to write the unit digits like this. Okay, I hope you are clear, and if you are not clear for the first time, do revise this concept from the number system.